Time series or time series data is nothing but the arrangement of data in accordance with time, which could be years, months, or days. Let us take the example of a time series data on the sales of cars. Sales of cars. So suppose when we have data on how many cars were sold from the year 2001 to 2010, okay, and for each year we have the amount of cars that were sold. That is a time series data. And if we plot it in a graph, okay, if we plot it in a graph, it looks something like this. So what we can say from this graph is that there is movement in the data. There is movement in the data. And this picture of the movement of data, okay, which is a time series data on the sales of cars from the year 2001 to 2010, okay, will give us an idea on the components of a time series, which include the trend, seasonal variation, cyclical variation, random or irregular variation. Now the trend is nothing but the tendency of a time series data to increase or decrease or remain the same during a long period of time. So in other words, we are looking at what is the general direction of data, whether it is moving up or down or remaining the same. Contrast that with the cyclical variation. Cyclical variation, okay, of a time series data shows us whether the data is having, or what we call is displaying, oscillatory movements or up and down movements. Whereas the trend gives us only one direction, the cyclical variation or cyclical variations or behavior of data shows how data moves up and down. Seasonal variations, when data is arranged in months or quarters, which means a period of 4 months, then we have seasonal variations. And random or irregular variations or irregular behavior of data happens because of unforeseen or unpredictable factors. For example, an increase in the number of sick people or dead people because of an earthquake or a pandemic. Okay, these can influence the movement of data. So let us look at this diagram over here so that we can understand the components of a time series better. So if we are looking, let's say, at the behavior of data between this year and this year, we find that between these 2 years there's a certain movement of data. Okay, so these movement between 2 years, okay, they are an example of seasonal variation of data. And if we look here, we find that at this point here, there's a movement from a low point to a very high point. Okay, this is called an irregular variation or an irregular fluctuation. And when we look at the movement of data over many years, okay, this gives us an example of a cyclical component of a time series data. And if we look at the tendency, which means the direction where data is moving, okay, this explains the trend component of a time series data. For the moment, we will be looking at time series data that are arranged over long periods of time, which will spread over many years. So we won't be dealing with seasonal variations, okay, but we'll be looking at the trend, the cyclical variations, and random and irregular variations. So when dealing with these long-term movements in data, okay, there are certain methods used, and we will discuss some of them. So after we've seen that there are different components of a time series data, or in simple words we can say different behaviors or movements of time series data, we proceed to the methods for finding out the components. So in other words, we try to look at the time series data and find out and try to find out which part is the trend, which part is the seasonal variation, which part of the data or movement of data shows cyclical variations or shows random or irregular variations, and so on. So first we look at the methods of determining the trend. In other words, we are trying to find out the general tendency or the general direction where data is moving. And like I've said before, when we are dealing with the trend, we're looking only at one direction, whether it is up, whether the data is going down, or the data stagnates or remains the same over time or over the years. So suppose we have data, and if we plot it in the graph, this data looks like this, okay, as shown in this diagram. So if we look at this diagram over here, we cannot really say whether data is moving up or moving down, because there are other components of this time series data. If you look at the graph here, there's seasonal variation, okay, which means we are talking about monthly data, we will have seasonal variations. We have cyclical, okay, if we look at this entire part over here, let me change the color of the pen. So we take this, because these are short term, remember, seasonal, so this could be in months. So let's say in this year, we take this, becomes the cycle, okay, of this data. And we also have irregular variations at this point over here. So we can't really say whether over the years, let's say this chart represents the sale of cars over the years from 2001 to 2010. So we can't really say whether data is going up or going down. So that is where we are concerned. That is where the analysis of the trend comes here, which means you want to know whether it is going up, going down, or remaining the same. So after using the different methods, you find here that the general direction is moving up. Data is moving up. Okay, so in some books, the secular tendency is nothing. It means the trend only. So we find that when data looks like this, but when we find out the trend or general tendency, we find that it moves up. So that is a way of understanding the meaning of finding out or determining the trend. So we've already covered this first method, which is called the method of least squares. Okay, the least squares method. And if you remember, this is nothing but a mathematical method. Mathematical because we make use of some formulas or equations. Normally we call them normal equations, or we call them as simultaneous equations. Simultaneous, why? Because we have two equations occurring at the same time, or working with both of them, and using these equations we can find out either the value of A or B and substitute those values to this equation over here. So suppose if we find out the value of A using these two equations, then we can put the values of A in either one of these equations to find out the value of B. So once we get the values of A and B, we can substitute them in this equation, which is called the equation of a straight line. Okay, and that helps us to find the trend values for all years. And using this equation, we can also find the trend values either for future years, okay, or we can go back in time and find out the past values, meaning what was, let's say, suppose if this data here represents the sales of cars from the year 2000 to 2010. So using this equation, we can find out what was the sales of cars in the year 1999 or 1998. In other words, we can go back in time. So after determining the trend, what we can do next is, because yearly data has trend components, cyclical components, irregular components. So suppose in the question it is asked, find out, after eliminating the trend, find out the other components, or find out that part of data which shows cyclical variations or irregular variations. Now remember, again, yearly data will only have trend, cyclical variations or movements, and regular movements or variations. If we have monthly data or quarterly data, then we will also have seasonal variations. So this all depends on the relationship we assume to exist between these components, or if you still remember we have the additive model, multiplicative model. Suppose the question asks you or tells us that assuming an additive model, eliminate the trend and find out the other components. So using the additive model, which says that these trend components are independent, we can simply subtract the actual values from the trend values, and this way we can find out the other components. That is a cyclical variation, irregular variations. And if you assume a multiplicative model, if it's asked or it tells us that we, based on the multiplicative model assumption, we have to find the other components after eliminating the trend, we can eliminate the trend by dividing the actual values by the trend values, multiply it by 100, and we get the other components of the trend. So using the moving average method in determining the trend, so we are dealing with other components, irregular fluctuations and the cyclical variations. Okay, so what we're trying to do is we try to lessen or eliminate or reduce the influence of these parts or these behaviors of data in order to determine the long-term movement of data. Okay, so usually cyclical and irregular fluctuations are clubbed together in the long run. Okay, so we will deal with cyclical fluctuations in general. So when using this method, which is a non-mathematical method, the concept of moving average or period moving average is very important, and it is here that we will talk of another concept which is known as the length or period of a cycle or a business cycle. So let us break down a cycle. The highest or the high point of a cycle is called a peak, the low point is called a trough, another high point peak, so on and so forth. So when we deal with time series data, so for those years, okay, where data has a high value, that is called a peak. When it goes down and has a low value, that's called trough. When it rises back and has another high value, that is called a peak. And the distance between two peaks, okay, it is called the length of a business cycle. Now the distance between two troughs also gives us the length of a business cycle, but we will be talking only about, for now, the distance between two peaks. Okay, so to understand this further, let us say we have 2 years, okay, of a time series data. Now the peak or the data has a high value at 2005 and 2007, so these are peaks. The difference between these two is equal to 2. Okay, let us say another high point or a peak occurs at 2009, sorry, and the distance between these 2 years or these two peaks is 2. So in such a case, when the length of the business cycle remains the same, or in other words, it is uniform, okay, it is uniform, we call that as a regular or a very uniform period of a business cycle. Okay, so it is this period of the business cycle which determines the period of moving average. Okay, and this period of moving average, when using this method, sometimes it is given already, sometimes it is not given in the question, and there's a process which we need to follow in those cases. Okay, so if the period of moving cycle is 2 years, it means the period of moving average will also be 2 years. So what happens? For the given set of years of a time series data, we will divide them into two groups, okay, which means we try to move for every two groups, we try to find the average until we arrive at the value which is interpreted as the trend value. Now if the length of the cycle or the period of the cycle is 3 years, okay, we will have a 3-year moving average, and we divide or we try to we evaluate the trend value, okay, using a group of 3 years. If it's a 5-year moving average, 5 years. If it's a 7-year, or if the length of the cycle is equal to 7 years, we will have a 7-year moving average, and so on. Okay, so but remember, because when using this method, we don't have trend values for all years, unlike the least squares method, which gives us a trend value for all years, and the longer the period of moving average, which should coincide with the length of the business cycle, the greater the number of years for which trend values cannot be obtained. and it does not give us a mathematical function like least squares method, which gives us y equal to a plus bx, and using that function we can predict future values or calculate past values. But this does not give us that. Okay, and keep in mind that the general rule of this method is that when the period of moving average is equal to the length or the period of a business cycle, that is when we are able to eliminate the influences of these other two components. Or in other words, we are able to remove the cyclical and irregular behavior of data. Okay, and that is when we can only and that is when we can find the trend easily. Now, when the length of the business cycle is not regular, what happens is, in that case, this method does not completely eliminate oscillatory movements or these cyclical and irregular variations. So this arises, okay, for example, when the distance between two peaks is not the same. For example, let's say the distance between this peak and this peak is 3 years. The distance between this peak and this peak is 2 years. The difference between this peak and this peak is 5 years. Okay, so we see that the business cycle does not have a uniform length or uniform period. So in this case, the moving average method does not completely eliminate the influence or of cyclical and irregular variations, which affect the behavior or movement of data over years.